Welcome to the Rise Inside podcast, hosted by Justin Starbird and powered by Rise Robotics. Listen as host Justin talks to experts from the Rise team about topics relating to mechanical engineering, industrial design, commercialization, and innovation. True collaborations work when ideas are integrated at inception to solve significant problems. Rise Inside brings together how the team continues to work with great folks to commercialize ideas. You're listening to the Rise Inside podcast. Here's your host, Justin Starbird.
Welcome back to Rise Inside. My name is Justin Starbird, and today I am fortunate enough to have Toomas Sepp, Vice President of Engineering, and Ken Gray, Vice President of Business Development with me this morning. Guys, welcome.
Thanks for having us.
Justin, great to be here.
You know, I always exciting to talk to both of you. For different reasons, every time we speak, I learn something new. And you know, Toomas, it's been so cool to hear from the rest of the team, you know, about your involvement and how you got started. But I'd love to hear from you a little bit about yourself and your background.
So, my background is mechanical engineering at MIT. I took a few classes together with Blake. We're kind of acquaintances during undergrad. And right after undergrad, I went over to Vecna Technologies, which is also in Cambridge, Massachusetts. They've since moved. This was 10 plus years ago. But we did a lot of small-scale hydraulics work there. And that was really interesting and everything. But upon reconnecting with Blake after graduation and meeting Aaron, actually separately through mutual friends, also through MIT connections, kind of became very, very interested in this idea of what Rise Robotics would eventually become. I suppose it wasn't called Rise at the time.
Right. Well, I didn't know that you were classmates with Blake. I knew that you had met early on, but I didn't realize you guys were classmates too.
Yeah, there's a handful of classes that we were all in the same class together with. No big group project classes where we collaborated closely. More like lecture classes. So
yeah. Oh, so like one of 100.
Yeah.
Well, cool.
Yeah.
So how?
Just for context, for those who are unaware, Blake and Aaron that Toomas is referring to. Blake Sessions is our chief technical officer, an MIT grad, and Aaron Acosta is Rise Robotics CEO. And these are Forbes 30 under 30 quality people. So I just wanted to establish that context.
Yeah, no, thank you for that. And you know, Toomas, what was it that Blake shared with you that started to get you moving and get you excited about what they were working on?
Yeah, I actually remember it very viscerally.
Viscerally?
Yeah, I do. I know exactly where I was in my apartment in Cambridge at the time when we were talking over some beers, and just the idea of a exosuit that you could wear that was comfortable, that had lots of energy storage potential in it. So the words that we often describe it is like a trampoline suit. So you just jump, you can jump bigger, you can keep jumping higher and higher and higher, or in this case, running faster, that type of thing with a suit, mostly talking about just the leg, like pants, quote unquote pants portion.
And a little known fact about Toomas Sepp is that there's never a trampoline that you can't go jump on, right?
Oh yeah, you heard that one? Yeah. So very, very athletic, into a lot of like the extreme sports. So we would often go skiing and kiteboarding together.
Mm-hmm.
More so in the earlier days. We're trying to get back into it, but we've become much too busy.
Well, talk a little bit about that initial vision that you had, because that sounds really exciting as well. I mean, it's what do they say? If you follow your passion, you never work a day in your life, and it seems that certainly all four of the founders, have certainly taken that to heart.
Yeah. So that idea, that fun aspect of it, the playful, like working on something that I myself would want to use. We were all doing it for that. And then the other side of that is also, we actually do love engineering, and the technical problems and the challenges that need to be solved to really make this into a reality were also super exciting to us. So in the early days, we were working with fiberglass springs, which are a very, very energy dense form of spring in terms of their mass density and how much energy they can store per unit mass. So an ideal material if we want to store as much possible energy literally on a person as possible. Mm-hmm. So you want a lightweight, like as unobtrusive as possible exoskeleton. You want the lightest possible energy storage material or medium as well. So we were optimizing and working with these fiberglass springs to basically compact what would be a very large leaf spring in a more typical way of using the material into this very dense, we have a few different names for it, but there was the fiber block and also the flight source spring. Flight source was the first name, I think.
Yep.
There must be some video. There, I think there's some video. Is there some video out there of flight source? I think it's.
Yeah, I could pull some. I could dig some up that I have.
In the future on the website, we'll put some of that cool video up of about around flight source and some of the other really cool designs that flowed from Rise in the first 8, 9, 10 years of the business.
Yeah, there's a lot of them actually. We can actually make more video too of the flight source. There's 3 working ones in the lab, in a springboard. So that's the next thing we did to demonstrate the spring technology we're working on. This is one component, one small piece of the exoskeleton puzzle, among many others. But at one point we put the spring portion into a springboard.
Yep. And so, initially there was a vision to take that commercial, and of course the market for that, it wasn't non-existent, but you'd have to kind of create it. But that was your first opportunity to really kind of look through the commercial process, no?
Yeah. There's more of a, I guess there's one way of saying it. We working in the exoskeleton, and not just like the exoskeleton space where there's a market for medical or like paraplegics, and then there's also military. We were largely not focused on any of those. We were focused on a market that didn't quite exist yet, which was like the exosuit, like fun market. Kind of like, you maybe make some analogies to some kids' toys that are out there, but we really wanted something that was much higher performance than that.
Sure.
And then the springboard, there's definitely a market for springboards in some sense. a gymnastics thing, but again, not it's more, it's like a toy market. You
I was gonna
probably
say,
get a lot
putting
of
the springboard in the Olympics. I mean, that would change some scores at the end.
yeah. Well, they have the vault.
Yeah.
Has the springboard on it.
No, I mean your technology, putting that in there.
Oh,
and,
yeah.
And seeing them, they'd fly right over the sawhorse, right? So, well,
Yeah.
So what made this vision clearly? It was initially going down one path and in a certain direction. You've made a couple of pivots though over the years.
Yeah.
Talk a little bit about some of the early pivots.
Yeah. So that actually that question brings us really well into like a kind of chronological order of our first like biggest, largest pivot was definitely from working with the fiberglass springs to electric linear actuators. So powered actuation as opposed to passive energy storage and release. That pivot was a very dramatic pivot. I would still say that's the biggest pivot we've ever had over the 10-year history.
And was that something that the four of you were in complete agreement with, or was that something that it was, was it any challenges?
Kyle hadn't joined yet at that point. So this is in 2013, the summer of 2013.
Yeah.
And yeah, it was a difficult pivot, but it was a very small team. It was just me, Blake, Aaron, and we had, I think we had like 2 or 3 interns at the time during that summer. And it was difficult in one sense, but relieving and easy in the other, which is why we knew that it was the right thing to do.
Mm-hmm.
We were having a lot of issues with finding market traction on the spring, and I kind of alluded to, the market didn't exist in the way we wanted it to. There's some like adjacent markets that you could try to like put it into, but it's not really what we wanted to do.
Mm-hmm.
We didn't want to. So, but we were still driven, and we still very much are in terms of the exoskeleton and like, very high performance, lightweight machines that you could wear. And that's where, a big transition to the powered actuator space happened.
Sure.
And we kind of looked at things and we're like, well, if we were to make a powered exoskeleton, what would that look like? What kind of actuators would we use? What motors would we use?
Mm-hmm.
And we didn't want to use any of the stuff that's out there. I mean, I know from my experience from hydraulics that you can't make a lightweight hydraulic system.
Right.
So you're not going to do that.
Right.
And we had no desire to do that. Air power and pneumatics, that might be a little lighter. And the reason I bring out those two as potential options first is the power.
Sure.
Like hydraulics have a lot of power, and so do pneumatics. Pneumatics have a lot of other problems with control and positional. Like, you don't have that. You don't have any fine control, even worse than hydraulics. And then beyond that, there's not much else that can qualify as like a powerful type. There's powerful motors, but you always need to put big heavy gearboxes on them.
Right.
And it becomes something you don't want to wear. So that wearable aspect and the very root of the company forming in the first place of wearable technology, wearable exosuits, that's what drove us to really try to develop a different type of actuator entirely.
So where were the opportunities? So as you're talking about like, going to lighter, faster, materials, you're also trying to solve a problem in a way that hasn't been done before. Right. So if you're eliminating, motors, you're eliminating pneumatics, you're eliminating hydraulics. Now all of a sudden you still want to get the same results. Where were the opportunities you saw there?
So we started off small. We were 3D printing a lot of different geometries, still trying to figure out what is this design or actuator that we're looking at. And we started off small. We were looking at things like FIRST Robotics, something that an actuator that's cost effective, lightweight, and powerful. Would be extremely valuable to a FIRST Robotics team, or really like the next level of that is any engineering team that is building, something that needs to move and needs higher power. And the reason we started with like FIRST Robotics, and we worked with a local high school here in the Cambridge area as well to do some projects with them. Just to see how they could be used and learn from that, from like actually getting the quote unquote users or other people other than ourselves to try to do something with them.
And then one of the discoveries you made, and Blake made, what was that like, in terms of, changing the game for the design, with the, ultimately you settled on, a belt driven, apparatus. What led to that, and what did that do for you guys?
Yeah, so over the years, we went through a bunch of different iterations. The main like common thread among all of them, pun intended, is that we're dealing with flexible tensile elements. So high performance aramids, Kevlar, Dyneema, and then eventually going up and finding these flat belts that had been developed kind of at the turn of the 2000s, probably before that, but they began to be really used in industry, especially the elevator industry in the early 2000s. And these belts, they're polyurethane belts that are steel wire rope reinforced, very similar to a timing belt, except for no teeth at all. And for that reason, also very much higher performance than timing belts as well.
Sure.
And so we found this like ultimate tensile element that we began saying like, this is it. If we're going to make something super high power, we're going to be doing it with this. And so we made some prototypes of actuators with it, but more importantly, especially for the company and how we're positioned now with our patents and everything, we invested a lot of time and energy into just testing those belts. So fully understanding them, how much load can they do, how many cycles can they do it for. And the key thing here is a belt will wear ever so slightly every time it bends on and off of a pulley. So just there's internal frictions happening inside the wire ropes. It's gonna have a finite lifetime, given a certain load and a certain pulley diameter, which basically defines like how much much internal stresses and internal frictions are happening. So we designed our own custom belt tester, and we had like
the UL should be calling you guys, right?
Yeah. We had a sampling of pulleys made, all different pulley sizes, all of that. And this discovery that you're asking about is really, just a result of doing the testing and asking the question, what is happening here? What we ended up finding, we were testing twisted sections of belt because we again, driven by how small can we make this? How lightweight can we make it? How compact can we make a powerful actuator? So in order to achieve some of those metrics in the best, in like kind of the best way possible, we'd want to put twists in these belts. We want to make the pulley diameters as small as possible. So we're testing all these different things, and the twisting is really the key. When we were testing the twisting, we started to test very, very aggressive twist ratios. Basically, how long of a belt can you twist for a 90-degree twist in the belt if you need to change the axis of where the next pulley is going to be routed to? How close can you make those two pulleys that are 90 degrees apart on axis? And how long will the belt last if you do it? And from all the industry experts, all of the literature on any of these belts, any belts at all, really, will say you can't do it. Don't twist a belt, and especially don't twist a belt over a very small distance, because you end up stressing the belt, and it ends up not lasting as long But what we found when we did this was the belts lasted much, much longer than they should have. And so just realizing that and continuing to pull on that thread and ask the questions like, why is this? What's happening?
What did that do for the team? Like, what is it, how exciting was that? Or was it an aha moment, or is it something like it happened over a couple of weeks or a couple of months?
There was definitely an aha moment. I think that probably came from when Blake went to the pen and the paper and tried to back out what was actually happening, the mathematics of it. But there's also a big buildup leading up to that, where the tester is still going and the belt hasn't broken after day 5, day 6, day 7. We're in the second week now, and the same section of belt with the same twist, with the very aggressive twist ratio, it's like, this should fail tonight, like when we keep it running overnight, like for multiple days in a row. So there's like this buildup of like, is someone playing a trick on this? Like,
is somebody coming back at night? Right.
Yeah. Is someone replacing this with a new belt every night?
So now you don't trust each other. Somebody need like a game cam on there. Like, hey, this is what's going on.
Yeah. But to answer your question, I'm laughing about it, and it was very exciting.
I bet.
And then even more so exciting, like over, the month timeline, when we, filed patents on it and realized that this is a very fundamental patent and defensible position at a very root base level that can apply to so many things.
Absolutely.
So that added a lot of value to the company, and has definitely contributed in its own way over the years to raising various rounds of funding and such.
And so where did you see, I know where we are today, but, at that time, you were kind of drawing on your hydraulic background too, right? And saying, hey, there's a chance that this could be really useful in certain industries.
Right. Yeah. So definitely keeping our ear to like what's going on at Boston Dynamics. The robotics, humanoid robotics, like the big dog, things like that. There's definitely, and they've always been. This is before they were bought by Google even. But there's always been a lot of excitement around those types of machines, even though there's not quite a market for them even today. There's a lot of excitement on YouTube with the videos that Boston Dynamics has been able to create. And so, part of our drive there is this could be applicable, a lightweight, compact, powerful electric linear actuator that could be applicable to machines like this, that robotics, and really even enable a market to start to form around machines like that. If you really could make a lower cost way of high power actuation.
Well, and talk a little bit about what that's doing today. Like, talk about a little, your new partnership with Anthony Liftgates, and how all of this work has come into your first opportunity to commercialize.
Yeah, so we went and we realized that this is actually from pretty early on with these flat belts, and the reason we were testing them so vigorously is we realized that they have the performance capability to displace a large variety of actuators, including hydraulics. So we started getting into hydraulic applications, and we met a liftgate company who we recently announced a partnership with, Anthony Liftgates. And we have been working over the last 2 years to bring the actuator from a more prototype stage into a fully developed and tested product that can go out into the field and really live for 10 years on the back of a truck. So dealing with IP ratings, environmental protection, vibration, shock, weather, all the things that come with putting anything on the back of a truck, especially in cold weather, outside,
right,
rain, snow, salted roads. So the last 2 years have more been about productizing, doing all the things on top of the fundamentals of the actuator geometry and technology that we had proven.
So what will this partnership do for, both Rise, but also Anthony? How does it help them differentiate themselves in a market where they pioneered, early on, but then, now they have some, room in the market to gain traction again?
Yes, that's exactly what it's doing for them, and us as well. The name of the game for both of us is to go and capture more market share. For them, it's differentiate themselves in order to capture more market share in the railgate, liftgate product. And for us, we're trying to capture more market share in all hydraulic applications.
Yep.
This one in particular is a really good beginning, like first application for us, because like I've mentioned before, lightweight, powerful has been our drivers. The other side of that is the efficiency aspect.
Yeah.
So I actually didn't mention efficiency, but efficiency was always very, very high priority from the beginning, because if you're going to wear an actuator, going back to the roots of the beginnings of the company, you want to have the smallest battery possible that you might have to carry around with you. So from that, the energy density and power density also has to include the battery weight.
Sure.
So efficiency is a huge thing, and that's what the biggest benefit to Anthony is. It's that efficiency that allows batteries to be smaller on the machine, and really not be used as heavily, not be overused as the batteries currently are on the hydraulic lift gates. And what that does is it reduces maintenance costs. Fleets will no longer have to preemptively replace batteries on all of their trucks for their lift gates. Among the maintenance aspects of just having no hydraulic leaks anymore, which is a big deal.
Absolutely.
So that's the first all electric lift gate ever. That's the differentiator, and it manifests itself from a customer value perspective in just total cost of ownership.
That's really exciting
over the lifetime.
Yeah, and that's so exciting, especially today. We're sitting in the fall of 2021, where you're in Boston. I'm even a little bit further north, and heating, oil, all the different elements are scheduled to go up. So creating an opportunity where you don't have to maintain it is a huge benefit, and potential for huge benefits.
Yeah.
So,
yeah, and then
go ahead.
So we have some other partnerships on the horizon that we're working to do different applications, other hydraulic applications, where the benefits are similar in many ways, and then also kind of exaggerating that efficiency aspect. So we're demoing a 50,000 pound cylinder very soon, in the next few weeks, and that will represent the sizing of our technology that can go into a container handler.
Yeah.
So like basically the largest forklifts out there, moving containers around the shipyard, stacking them 5-6 high. And in a machine like that's doing such large amounts of work, picking up large weights and bringing and lowering them, the total cost of ownership just from an energy usage side, like you said, gas prices, oil prices are scheduled to go up. Doing the lifting with an actuator that uses less than half the energy to raise something, and then recovers 75% of that energy when it's lowering it back down and recharges the battery. That's a game changer for total cost of ownership and just energy costs compared to a diesel machine. Yep.
That is so exciting to hear about it, and so exciting to see the growth, the effects that a pivot can have on a business, and how the vision, you just brought it all the way back to the exosuit, in that at the end of the day, being able to reduce weight, improve efficiency, and make things stronger is really, at the end of the day, what you're really trying to do. So that's really exciting.
Yep.
Are there any other opportunities you see out there, or things that your passion continues to get you up in the morning for?
Yeah, I mean, I get up in the morning every day to grow the team now and build the company. So my job has certainly transitioned a little bit away from the real like CAD oriented, or like the detailed design of the mechanical engineering, and more to all of the other hard things that go along with having a successful startup. So I would say the next few years of Rise are more about executing and figuring out the exact design that of our actuator that will scale into as many applications as possible. Mm-hmm. The same design, and we're positioning ourselves, and we have been positioning ourselves as best as possible to answer those questions. With Ken, who had been here earlier, VP of Business Development, he's reached out to hundreds of different OEM companies mm-hmm. and parties interested in getting rid of their hydraulic machines. So we've been developing basically like a database of what are all these applications, what do they look like, what are the exact requirements, so that we can leapfrog over our first application, and for the next product, probably it'll be a group of different actuator sizes that we develop and test and bring to a level that engineers can buy them and use them in their machines. Mm-hmm. We're well positioned to pick the highest impact design that will affect the most amount of applications and replace, basically try to grow the company in a scalable way.
Yeah. That's
super exciting. That's super exciting to get to that point.
Yeah. Hey, listen, I'm so happy to be a fly in the wall and help get the story out and hear not just about how it came to be and then what you've done, but also where we're going. I think that's a lot of fun. Well, Toomas, thank you so much for joining me today. Ken Gray, thank you for joining me as well. I appreciate it, guys. Until next time.
You have been listening to the Rise Inside podcast, presented by Rise Robotics. On behalf of our guest today and host Justin Starbird, thank you for listening. Please share your feedback on our LinkedIn page, linkedin.com/company/rise-robotics.